As we continue our quest for equations that will describe how pressure, volume, temperature, and number of moles affect each other in gases, we realize we haven't changed the number of moles. We haven't added any gas to our sample or removed any gas from our sample. We've just been juggling pressure, volume, and temperature. So as we move into allowing for allowing for the number of moles, we're going to have to switch over to another law called the ideal gas law. And the ideal gas law is also a very simple equation. It tells us that PV equals nRT. Now notice there are no subscript 1s and subscript 2s. We're not changing anything in the ideal gas law. We're not changing the pressure or changing the volume or changing the temperature. We're just saying if we know 3 of these, what will the 4th one be? If we know the pressure, the volume, and the number of moles, what will the temperature be? If we know the temperature, the number of moles, and the volume, what will the pressure be? If we know any 3 of these, what will the 4th one be? Now, we've got this ugly R sitting there. The R is necessary. It's a constant of proportionality. So that rather than just saying pressure times volume is proportional to number of moles and temperature, this allows us to actually be equal. So what is the value for this R, this gas constant? Well, it depends on what units you've chosen for the pressure. We're assuming that you're going to keep volume in liters just because that's convenient. We're assuming that you're going to keep temperature in kelvins, which you darn well better because otherwise the equations don't work. We're assuming that number of moles is in moles, but we've got several different options for pressure, and that's kind of inconvenient. Well, it turns out that if you measure pressure in atmospheres, then R is going to be 0.08206. If you measure the pressure in torr, then R is going to be 62.4. Big difference there. But then there's a big difference between a torr and an atmosphere. If your pressure is in kilopascals, then your value is going to be 8.314. Now you have a choice here. You can either memorize these 3 values and what pressure unit they go with so that you use the right one for the pressures that you're given in the problem. Or you can do what I do and remember one of these and then just convert the pressure that you're given in the problem to the unit that you remember the value of R for. I find that easier, but you're perfectly welcome to do it either of the other ways if you would prefer. All right, so here again, this is a very straightforward plug and chug kind of a situation. So let's look at an example. All right, so let's go through our problem, and as we run into a number, let's list it. I have 10 milliliters. That's a volume, but remember that we usually keep our volume in liters. This is milliliters. And so to use any of these values of R, I'm going to need to change this to liters. We know that 1 liter is the same thing as 1,000 milliliters. So there we go. We've changed it to liters. Read. 1 atmosphere. That's my pressure. Now I just happen to like 62.4. I don't know why. I just do. That's the one I remember. So I'm going to change atmospheres into torrs. Well, since it's 1 atmosphere, that's very easy. That's 760 torr. Read. 30 degrees Celsius. That's a temperature. Whoops, Celsius. Can't do that. Got to add 273 to it. And they're asking for the number of moles. Well, once you've changed it from a word problem into a list, everybody feels better. And so you look through and you say, okay, that's an ideal gas law problem. So tell me so, and then plug in your numbers. And then you can solve it quickly and easily in your calculator. So here's my calculator. So 760 times 0.01 divided by 62.4 divided by 303. Looks like I'm going to have, how many sig figs do I have? 2. Alright, looks like I've got 4.0 times 10 to the negative 4th moles, which is still an awful lot of particles. But then this was a syringe, so it's not a whole mole's worth of particles, nor even close to it. Alright, straightforward. You can solve for any of these as long as you know the other 3. You've got to be given 3 to be able to solve for the 4th one. And then you just pick whichever R value suits you. Enough said? Enough said.